Video, we're going to go over finding critical numbers and everything that goes along with that, all the absolute extrema, the relative extrema, increasing, decreasing intervals, the first derivative and test and the second derivative test, and everything that all of those applications of that process. So first of all, let's talk about critical numbers. Critical numbers are where your derivative equals zero or does not exist. Now, this is very important because remember, your derivative is finding your slope. So if your slope is zero, that's where you're going to have a turning point or a minimum or a maximum. So finding the critical numbers tells you a lot about the graph. So when in doubt, find the derivative and set it equal to zero. That is usually about half of what we're going to do here. So first of all, let's find absolute extrema, which is on a closed interval. So this is going to be kind of your cheat sheet to find everything. Absolute extrema, first thing you're going to do is you're going to find the critical numbers. Which is take the derivative and set it equal to zero. Then we're going to make a t-chart, and you're going to test the critical numbers and the endpoints of the interval to see what gives you the biggest and the smallest value, or your minimum and your maximum. And when I say test, that means in the original equation. So you're testing them in f of x. And that will tell you your least value will be your minimum, your absolute minimum, and your greatest value will be your absolute maximum. So it could be one of the critical numbers or it could be one of the endpoints. So that's if you're asked to find absolute min or max or absolute extrema, those are your steps. To find increasing or decreasing intervals, again, we're going to start out the same way. Find the critical numbers. You're going to set up intervals around those critical numbers. And then you're going to pick a point in each of those intervals that surround the critical numbers to see whether the slope is increasing, decreasing, or constant. So pick a point in each interval and plug it into the derivative. Which is going to tell you if your slope is positive or negative. So if the slope is greater than zero, you're going to be on an increasing interval. If the slope is less than zero, you're on a decreasing interval. If the slope equals zero, you're constant in that interval. So it's a straight horizontal line. So that's for increasing, decreasing intervals. Let's look at your first derivative test. The first derivative test can be used to find local or relative min and max. which is on an open interval usually. So when you're asked to find local, it doesn't have to be the absolute min or max. It's just really a maximum or a minimum or a turning point where your slope is changing from positive to negative or negative to positive. The first derivative test are the same steps as above. So you're going to find your critical numbers, set up intervals, pick points in those intervals, and plug it into the first derivative. And then you're going to kind of see what's happening to the slope. So if the derivative changes from negative to positive, which would look like this, that means you have a relative minimum. If the derivative changes from positive to negative at that critical point, or around that critical point, positive and then goes negative, that means you've got a max. If it doesn't change, then you have neither. And graphically, that can look like it does zero out right there, but it's still decreasing and decreasing, or the other way around, positive and positive, but it didn't change direction. Okay, when you're asked about concavity, you're going to use the second derivative. Sorry. And it's basically if the second derivative is greater than 0, then you're concave up, which looks like that, which also means you have a minimum. If the second derivative is less than 0, then you're concave down. Which means you would have a maximum. So here, we're going to find the second derivative and set it equal to 0. This time you're going to use those zeros to set up intervals, just like we did before, but with the second derivative. So anything you found that the second derivative equals 0, you're going to use those to set up your intervals, and you're going to test points in those intervals. And here you're testing them in the second derivative. And that goes back to whether it's positive or negative. Points of inflection go directly with concavity. So if you have a change in concavity, that's going to give you a point of inflection. Okay, one more thing about the second derivative test. Now, we just used the second derivative, but that wasn't the second derivative test. The second derivative test can also be used to find relative mins and maxes. So you can use the first derivative by setting up the intervals like we did in the very beginning and testing to see what the slope is doing. But if you're asked to use the second derivative test to find relative mins and maxes, what it wants you to do is first find the critical numbers. And remember, those are from the first derivative where it equals 0. And then you're going to plug those critical numbers into the second derivative. And basically, if it's greater than 0, you're concave up, which means you have a minimum at that point. If the second derivative at that critical number is less than 0, you're concave down, which means you have a maximum at that point. The only other option is if that critical number equals 0, and that means the second derivative test fails. Which means you would have to go back to the first derivative test and test your intervals. Okay, so that's kind of a little cheat sheet on finding all your mins and maxes, concavity, and points of inflection.